Good morning. Welcome to Trinity online classes. I am VVN Suresh Kumar, lecturer in mathematics. A circle is inscribed in an equilateral triangle and a square is inscribed in the circle. A circle is inscribed in an equilateral triangle and a square is inscribed in the circle. The ratio of the area of the triangle to the area of square is the ratio of the area of the triangle and area of the square is. Solution. First, a circle is inscribed in an equilateral triangle. First, we draw the circle. The circle is inscribed in the equilateral triangle. This is the center of a circle is inscribed in equilateral triangle. This is equilateral triangle ABC. This is the circle and a square is inscribed in the circle. Square. A square is inscribed in the circle. This is the distance. The distance from center to any point on the circle is radius. This is the distance. This is also radius. Thus, distance from center to any point on the circle. We know that this is an equilateral triangle. Each of the angle is 60 degrees. Each of the angle is 60 degrees. The line in the triangle ABC for this is ABC. This is center will be taken as C1. Center of the required circle will be taken as C1. This join from B to C1 is angular bisector of at B. Therefore, this angle be 30 degrees. Total angle is 60 degrees. It is equilateral triangle. Total angle is 60 degrees. This is the line joining this is angle forms 30 degrees. This is the point of contact P. This is point of contact P. This is the radius small r. The radius of the circle will be taken as small r. This is radius. Actually, this is equilateral triangle. Total angle is 60 degrees. The joining C1 and B is an angular bisector. Therefore, this forms 30 degrees in the triangle of CBP. C1BP. In triangle, it is a right angle triangle at the point P because it is the normal. It is the tangent. This is the perpendicular. B in triangle C1B for it is right angle triangle at P. Tan 30 degrees equal to tan 30 degrees. C1B is the hypotenuse because it is opposite to the right angle. Tan 30 degrees equal to opposite side by adjacent side. This is equilateral triangle. We take length of the each side may be A. We take length of the each side may be A. This point of contact divides this is equal two parts. Total length is A. This part is A by 2. This part is A by 2. Therefore, the tan 30 degrees equal to opposite side by adjacent side. Opposite side C1P by adjacent side BP. Tan 30 equal to 1 by root 3 that equal to C1P small r. This is the radius of the circle. BP this we consider as A by 2. 1 by root 3 equal to 2r by A. Therefore, 2r equal to A by root 3. R equal to A by 2 root 3. This is the radius of the circle. Suppose A is the length of the each side of the equilateral triangle. Actually, we need the ratio of the area of the triangle to the area of the square. The area of the triangle is to area of the triangle ABC is to area of the square. Area of the square. We know that the area of the equilateral triangle is root 3 by 4 A square. We know that the area of the equilateral triangle is root 3 by 4 A square, where A is the side of the triangle, where A is the length of the side of the triangle, and the area of the square. The area of the square, actually if the length of the side is known, so the area of the square is side square. Here we know the diagonal. The length of the diagonal is the length of the diameter of the circle. Length of the diagonal is equal to the length of the diameter of the circle. Suppose the length of the diameter of the circle, diameter equal to 2 into radius. Length of the diameter equal to 2 into radius. Circle is, the square is inscribed the circle, length of the diameter of the circle is equal to length of the diagonal. This is the center, this is one end, this is other end. Therefore, suppose square, the area of the square is x square. If length of the side is, the area of the square is x square. If length of the each side is s, here length of the diagonal is known d. Suppose the area of the square is half length of diagonal, whole square. That equal to root 3 by 4. A square is to 1 by 2 into length of the diagonal is equal to the length of the diameter. That equal to 2 into radius. 2 into radius equal to 2 into radius 2r whole square. That equal to root 3 by 4. A square is to 1 by 2. 2r means 2 into a by 2 root 3 whole square. Cancel. Root 3 by 4 a square is to 1 by 2 into a square by 3. A square cancel. 2 times person. That equal 3 root 3 is to 2. 3 root 3 is to 2. Therefore, the area of the equilateral triangle 2. The ratio of the area of the equilateral triangle 2. The area of the square is 3 root 3 is to 2. In this problem, a circle is inscribed in equilateral triangle. This is the equilateral triangle. Circle is inscribed and a square is inscribed in the circle. Therefore, if we take length of the each side, all sides are equal because it is a triangle. Let it be taken as small a. Therefore, the length of BP is a by 2. This is the radius r. We take angle in the equilateral triangle is 60 degrees. This is angular bisector. We take this is 30 degrees. Tan 30 equal to C1P by BP. That equal to we take in this radius r equal to a by 2 root 3. Therefore, the area of the equilateral triangle is 2. Area of the square is 3 root 3 is to 2. C1 is a circle of radius 1 and touching both the coordinate axes. C2 is another circle which touch both the coordinate axes, and also circle C1 whose radius greater than 1. Then radius of the C2 is, in this case, C1 is the first circle of center C1, radius R1. C1 is a circle of radius 1. C1 is a circle of radius 1. Center of the first circle is C1. Radius of the first circle is 1. And C2 is another circle which touch both the coordinate axis and also C1. Here, radius of the second circle is greater than 1. R2 greater than 1. Therefore, R1 equal to 1. R2 greater than 1. That means R2 greater than R1. In previous concept, we know that any circle, any circle which touches both the coordinate axis, in that case center is R comma R, because it is the radius. The distance from any point on the circle to center is radius. Therefore, center is C R comma R. In previous concept, we know that any circle touches both the coordinate axis, then that situation center is R comma R. In this case, the first circle touches both the coordinate axis, and also another circle touches both the coordinate axis and touches the circle C1. Any two circles touch each other, that means either internally or externally. In this case, R2 greater than R1. Both the circles touch the coordinate axis. Only one possible, these two circles touch each other externally. That's why the diagram like this. This is the second circle. Second circle touches the coordinate axis. This is the first circle. This is the y-axis. This is x-axis. This is y-axis. First circle touches both the coordinate axis and the second circle. First circle touches both the coordinate axis and the second circle. This is C1. According to this property, center C1 is 1, 1. According to previous concept, circle touches both the coordinate axis, center is r, 1. Here radius of the first circle is 1. Therefore C1 is 1, 1. R2 is greater than R1 and C2. We take C2 is R2, R2. We take the center of the second circle is R2, R2. Because radius of the second circle is we take R2 according to this property. C1, C2. This is C2, this is C1, this is the origin. The C1 is a circle of radius 1 touching both the coordinate axis, and C2 is a circle which touches both the coordinate axis and also touches the circle 1. Then radius of C2 is, here these two circles are touch each other externally. We know that the condition C1 C2 equal to R1 plus R2. Here C1 is 1, 1, C2 is R2, R2. The distance between two centers C1 C2 equal to R2 minus 1 whole square plus R2 minus 1 whole square equal to R1 plus R2. R1 value is 1, R2 is R2. 1 plus R2. Squaring on both sides. R2 minus 1 whole square plus R2 minus 1 whole square equal to 1 plus R2 whole square. Square root cancel. Therefore R2 minus 1 whole square plus R2 minus 1 whole square equal to 1 plus R2 whole square. That equal R2 minus 1 whole square equal to R2 plus 1 whole square minus R2 minus 1 whole square. A minus B whole square. A square plus B square minus 2AB equal to A plus B whole square minus A minus B whole square, that equal to 4AB. 4R2 into 1. R2 square minus 2R2 plus 1 minus 4R2 equal to 0. That implies R2 square minus 2R minus 4R minus 6R2 R2 plus 1 equal to 0. Take factors R2 equal to minus of minus B plus or minus root of B square minus 6 whole square minus 4. Here A is 1, C is 1 by 2A, 2 into 1, that equal to 6 plus or minus square root of 36 minus 4 by 2, that equal to 6 plus or minus root 32 by 2. 6 plus or minus root 32 means 16 into 2 by 2. 6 plus or minus 4 root 2 by 2. 3 plus or minus 2 root 2 by 2. 2 comma 3 plus or minus 2 root 2 by 2 to cancel. Therefore radius R2 equal to 3 plus or minus 2 root 2. Here we know that R2 is 3 plus 2 root 2 only, because the 2 root 2 means root 8, that this is root 9, that value is less than 1. We know that R2 is always greater than 1. We know that R2 is always greater than 1. There is only one possibility. 3 minus 2 root 2 value is less than 1. That's why radius of the required circle is R2 equal to 3 plus 2 root 2. In this case, we use the previous property. Any circle touches the coordinate axis, then the center is R, R. Equation of the circle is x minus r whole square plus y minus r whole square equal to r square. Equation of 4 circles are x plus r minus a whole square plus y plus r minus a whole square equal to a square. Then the radius of circle touching all the 4 circles are. Then the radius of the circle touching all the 4 circles are. Here the given circle B. Here the given circle are x plus or minus a whole square plus y plus or minus a whole square equal to a square. This is of the form. Actually, first circle is x plus a whole square plus y plus a whole square equal to a square. This is of the form x minus h whole square plus y minus k whole square equal to r square. Here radius of the each circle is a. Here radius of the each circle is a, that is equal, and center of the first circle is actually circles like this: x plus a whole square plus y plus a whole square equal to a square. Next one is x plus a whole square plus y minus a whole square equal to a square. Next one is x minus a whole square plus y plus a whole square equal to a square, and x minus a whole square plus y minus a whole square equal to a square. Circles are like this. These are the 4 circles. Equation of 4 circles are, then the radius of the circle touching all these 4 circles are, the radius of the circle touching all these 4 circles are. Here C1, center of the first circle B, suppose a comma a, that is we taken as first coordinate. Center of the second circle, this is a comma minus a comma plus a minus a comma minus. In order we take C1 a comma a, C2 minus a comma a, C3 minus a comma minus a, C4 a comma minus a. Center of this is the first circle. This is all the circles are equal, that means the circles touch each other. The 4 circles are touch each other like this. The circles, 4 circles are touch each other. These are equal radius. This is C1, C2, C3, C4. These are centers of the 4 circles. Here, this is the origin. These circles are a comma a. This is first coordinate. Center is a comma k. That center lies on first coordinate. Maybe a is positive. That means radius is a. Because center is same, x coordinate and y coordinates are same, then the circle touches both the coordinate axis. This is minus a comma a. This is minus a comma minus a comma minus a. Actually, equation of the 4 circles are like this. Then the radius of the circle touching all the 4 circles. Here 2 circles are possible. Touching all these 4 circles are like this. This is the circle. Touching all the 4 circles. This is the circle touching all 4 circles. This is the largest circle, and another circle touching all the 4 circles. Only 2 possibilities there. 2 circles is possible there. One circle is touched inside this. This a circle which touches the 4 circles. This is one circle. A circle touches 4 circles. Only 2 possibilities is there. In this case, this is the distance. This is the distance from. This is the line. This is the distance from C1 C3. This is the distance from C1 C3. This is the also one of the circle. This is the point. This is the radius of this circle. This is the radius of this circle. Therefore, the biggest circle, largest circle touches these 4 circles is the diameter is R plus C3 C1 plus R. The diameter of the largest circle is the diameter of required circle. Circle B, diameter may be considered as small d, that equal to d. The diameter is, this is the diameter, the length R plus C3 C1 plus R radius of this, all the circles are equal radius a. Therefore, radius plus distance of C3 C1 plus R. This is the largest circle. Maybe suppose another circle, small circle which touches all the circles. Here it is C1 C3. This is R. This is R. Therefore, another circle is C1 C3 minus R minus R. Actually, this is inner circle, this is R, this is R. This is the inner circle. C1, C3 minus R minus R. This is the small circle. C1, C3 minus R minus R. We know that C1, C3, the distance from C1, C3 is square root of C1 is A comma A, C3 is minus A comma minus A. Therefore, A plus A whole square plus A plus A whole square, that equal to square root of 2A whole square plus 2A whole square, that equal to square root of 4A square plus 4A square, that equal to square root of 8A square, that equal to square root of 8A square, that is A square root of 8. Here the length of the largest circle touching the all circles is D equal to, D is the diameter of the required circle, equal to radius is A plus C1 C3 is A root 8 plus A, that equal to A root 8 plus 2A. A means 2, root 8 means 2 root 2 plus 2A, that equal to, we take 2A common, root 2 plus 1. This is the diameter of the required circle. Length of the diameter. Required circle in the large circle, small circle. C1, C3 minus 2R. C1, C3 is A root 8 minus 2A. That equal to A into 2 root 2 minus 2A. Take 2A common, 2A into root 2 minus 1. This is length of the diameter of the required circle. Actually, we need circle touching all the 4 circles are radius of the circle. The radius of required circle is, in this case, D is the length of the diameter. Radius R equal to 1 by 2 into, radius R equal to 1 by 2 into length of the diameter D, that equal to 1 by 2 into 2A into root 2 plus 1. 2 cancel, that equal to A into root 2 plus 1. Here also radius equal to half of the diameter D, that equal to half of 2 into root 2 minus 1. 2 cancel, that equal to A into root 2 minus 1. There is 2 possibilities. Suppose radius is A, the circle touches all the 4 circles. Largest circle is A into square root of 2 plus 1, where A is the radius, and the small circle touching these 4 circles is A into root 2 minus 1. This is the required circles. Actual problem is equation of 4 circles are, this indicates the 4 circles. Then the radius of the circle touching all the circles are. We take x plus or minus a whole square, y plus or minus a whole square. This is of the forms. In order, x plus a whole square plus y plus a whole square equal. In order, we take, suppose centers are like this. Every center, this is of the form x minus h whole square plus y minus k whole square equal to r square. Center is a comma b. That means the circle touches both the coordinate axes. Center x coordinate and y coordinates are same, like this. These are the 4 circles touches the coordinate axis. Actually, we need the radius of the circle touching all the circles. 2 circles are touching all the circle. One is the big circle, another one is small circle. In this case, radius diameter of the required circle is largest circle for C1, C3 plus this side R plus R. C1, C3 plus R plus R. Small circle is total length is C1, C3. This is minus R. Diameter of the second circle is C1, C3 minus 2R. Here D is the length of the diameter. Radius R equal to half of the length of the diameter. Radius of the required circles, largest circle is A into root 2 plus 1. Small circle is A into root 2 minus 1, touching the all circles of the radiuses. Let A and B be any 2 points on each the circle x square plus y square minus 8x minus 8y plus 28 equal to 0 and x square plus y square minus 2x minus 3 equal to 0. A and B be any 2 points on each of the circles, first circle and second circle. A is the first, lies on the first circle, B lies on second circle respectively. If D is the distance between A and B, D is the distance between the points A and B, then the set of all possible values of D is. Then find the set of all possible values of D is. Here the givens A and B be any 2 points on each of the circle. First we find the position of the circle. The given circle is x square plus y square minus 8x minus 8y plus 28 equal to 0. This is of the form x square plus y square plus 2gx plus 2fy plus c equal to 0. Maybe g1, f1, c1. Here x quotient is 2g1 equal to minus 8, g1 equal to minus 4. Y quotient is 2f1 equal to minus 8, f1 equal to minus 4. Constant c1 equal to 28. Center of the circle is c1 minus g1 comma minus f1 minus g1 comma minus f1, that equal to g1 is minus 4 minus g1 is 4 comma 4, and radius of the first circle is r1 equal to square root of g1 square plus f1 square minus c1, that equal to square root of g1 square is g1 is minus 4 whole square plus minus 4 whole square minus 28, that equal to square root of 16 plus 16 minus 28, that equal to 16 plus 16 32 minus 28 root 4. Radius of first circle is 2. Radius of the first circle is 2, and second circle is x square plus y square minus 2x minus 3 equal to 0. X square plus y square minus 2x minus 3 equal to 0. This is of the form x square plus y square plus 2g2x plus 2f2y plus c2 equal to 0. Here x quotient is 2g2, that equal to minus 2, g2 equal to minus 1, 2f2 equal to 0. There is no y term. Y quotient is 2f2, there is no y term, f2 equal to 0, f2 equal to 0, c2 equal to minus 3. Center of the second circle is c2 minus g2 comma minus f2. Minus g2 means 1, f2 is 0. Radius r2 equal to square root of g2 square plus f2 square minus c, that equal to square root of, here g2 square is minus 1 whole square 1 plus f2 is 0, c is minus 3, actually c2 minus of minus 3, that equal to square root of 1 plus 3, that equal to root 4, that equal to 2. Radius r2 equal to 2. Distance between the two centers is c1, c2. Here center of the first circle is 4 comma 4. Center of the first circle is 4 comma 4. Center of the second circle is 1 comma 0. The distance between the two centers c1, c2 equal to square root of 4 minus 1 whole square plus 4 minus 0 whole square, that equal to square root of 3 square plus 4 square, that equal to square root of 9 plus 16 root 25, that equal to 5. Distance between two centers is 5, and r1 plus r2 equal to, r1 is 2 and r2 is 2. 2 plus 2, that equal to 4. Therefore, c1, c2 greater than r1 plus r2. The two circles are away to each other, but both have equal radiuses. This is the first circle. This is the second circle. These two circles are equal radiuses, but away to each other. This is C1, center of the first circle, radius. C2. This is R1. R2. Here R1, R2 are same, both are 2. Okay. See, center of the first circle, radius of the first circle, center of the second circle, radius of the circle. Actually, problem is, let A and B be any 2 points on each of the circle. Not mention particular position. A and B are any 2 points on these circles. Maybe A lies here or here or here. Any position of these circles. A is lies any position of the circumference of the circle. B also lies here or lies here, lies here. Any point on the P is the any point on the circumferences. That means the point, this is C1, C2 is the length. Suppose A here, B is the length of AB equal to C1, C2 minus of R1 plus R2. Suppose A is here, B is here, that is the minimum distance. Suppose A is here, B is here. AB equal to C1, C2 minus of, this is R1, this is R2. R1 plus R2. A is here, B is here. The distance AB is C1, C2 minus R1 minus R2. Suppose the point lies this side of the circle, the point B lies this side. AB equal to, so this is the largest position, AB equal to C1, C2 plus R2 plus R1. C1, C2 equal, AB equal to C1, C2 plus R1 plus R2. Remaining all positions are, suppose A is here, AB, any chances, the distance AB lies between these two. Therefore, C1, C2 minus of R1 plus R2 less than or equal, any positions is that this is the locus, this is locus. AB less than or equal C1, C2 plus R1 plus R2. Because A is any point on the circle, B is any point on the circle, we need then the set of all possible values of D. D is the distance between AB. Suppose distance may be like this, like this, like this, any chances. This is the property. We know that the length of C1, C2 is 5 minus R1 plus R2 is 4. 5 minus 4 less than or equal to the distance between the points AB named as D. Less than or equal to the distance between C1, C2 is 5 and R1 plus R2 is 4. Therefore, 1 less than or equal to D less than or equal to 9. This is the property. Actually, let A and B be any 2 points on each circle. A is any point on the circle, B is any point on the circle. These two circles are away to each other. Then find out D is the distance between the points A and B. Suppose A is here, suppose B is here, any possibilities each are. D is distance between the 2 points A, B. Then all possible values of D is 1 less than or equal to D less than or equal to 9. Radius of a circle which touches both the coordinate axis and the line, being center lies in the first coordinate. Radius of the circle which touches both the coordinates. In previous concept we know that any circle which touches both the coordinate axis, center is radius comma radius, touches both the coordinate axis, and the line, and also touches the line x by a plus y by b equal to 1, being the center lies in first coordinate. Here two different radiuses is possible. Suppose this is the first circle, this is the line touches the circle and divides the coordinate axis. This is another circle. This is another circle touches both the coordinate axis. You get two different radiuses possible. One is the large radius, another one is the small radius. Radius of the circle which touch both the coordinate axis and the line. This is the line. The line be x by a plus y by b equal to 1. Being the center lies in the first coordinate. This will be taken as first coordinate. Suppose LCM, take LCM AB. Bx plus Ay equal to 1. Bx plus Ay equal to min AB. Bx plus Ay equal to AB. Take all our same set. Bx plus Ay minus AB equal to 0. This is the equation of the given line. Our required circle touches the line Bx plus Ay minus AB equal to 0. We know that any circle touches both the coordinate axes that center V R comma R. This line is a tangent to the circle applying condition of tangency. Applying condition of tangency. Here we know that condition of, you know that center is read R comma R and the line is Bx plus Ay minus AB equal to 0. Applying condition of tangency R equal to D, where R is the radius of the circle and D is the perpendicular distance from center to the tangent. From center to the tangent. Here always radius is R. D, distance from center to the tangent. We know that the perpendicular distance from x1 comma y1, the perpendicular distance from x1 comma y1 to the line ax plus by plus c equal to 0 is modulus of ax1 plus by1 plus c by root of a square plus b square. Therefore, the perpendicular distance from R to the line, that is BR plus AR minus AB by square root of x quotient b square plus y quotient a square. Therefore, R into square root of b square plus a square equal to modulus of BR plus AR minus AB. BR plus AR minus AB. Take remove the modulus. BR plus AR minus AB equal to plus or minus R into square root of a square plus b square. All are same side, R's are same side. AR plus BR minus of plus R into minus of plus R into square root of a square plus b square equal to AB. Taking R as common, b plus a plus minus or plus or minus anything is same. Square root of a square plus b square equal to AB. Therefore, R equal to AB by a plus b plus or minus square root of a square plus b square. Here AB by a plus b plus square root of a square plus b square. Here plus takes, that is the radius of the small circle. Here minus takes R equal to AB by a plus b minus root of a square plus b square takes, that is the radius of the large circle. There is two circles are possible. Radius of circles touch both the coordinate axis and the line. In the first coordinate, two circles are possible. The radius of the two circles is, one is R equal to AB by a plus b plus root of a square plus b square. Second one is R equal to AB by a plus b minus root of a square plus b square. This is the radius of the required circles. The centers of a set of circles, each of radius 3, lies on the circle x square plus y square equal to 25. The locus of any point in that set is, the centers of a set of circles, each of radius 3, lies on the circle, the given circle B. X square plus y square equal to 25. This is of the form x square plus y square equal to r square, where center of the circle is C1, that equal to 0, 0. Radius R1, radius of the circle R1 equal to 5. Here 25, that means 5 whole square. Radius of the circle, first circle is 5. The center of set of each circle of radius is 3. This is the circle of radius. This is the center. Center is origin. This radius is 5. The center of a set of circle, each of radius 3, lies on the circle. The required locus for all the centers lies on the circle. Lies on the circles. This is C2, C3, C4, C5. All the centers are lies on the circles. All the centers are lies on the circles. Each circle having the radius of 3. Each circle having the radius of 3. Each circle having the radius 3. This is the circle of radius 3. This is radius of 3. This is circle. This is 1. This is 1. This is. The centers of set of circles, each of radius 3, every radius is 3, lies on the circle, The locus of any point on the set is, the point lies here, any chances, maybe this is the one of the required circle. The distance is 3. Here total distance is 5. Suppose this is R2, this is the R1. This is total distance is R1. This is the center of the first circle. This is the radius of the first circle. This is R2, 3 units. This distance is equal to R1 minus R2. Suppose the locus point lies here. Suppose outside, the point lies outside this is the largest circle. This is the locus of the largest circle. Here the distance is 5 and additionally the distance radius of that circle is 3. 5 plus 3, 8. Actually formula. The locus of any point on the set is formula R1 minus R2 modulus less than or equal to C1 C2 less than or equal to modulus of R1 plus R2. We take center of the second circle is C2 is x comma y. The distance between R1, radius of the first circle is 5. Radius of the second circle is 3. The distance between the 2 points, center of the first circle is origin, second center will be x comma y locus point. The distance is square root of x minus 0 whole square plus y minus 0 whole square less than or equal to the value of R1 is 5, R3 is 2 is 3. That is 2 mod less than or equal to square root of x square plus y square less than or equal to mod 8. Squaring on both sides. Squaring on all sides. 2 square less than or equal to x square plus y square less than or equal to 8 square. That equal to 4 less than or equal to x square plus y square less than or equal to 64. Here the center of set of circles, each of radius 3 lies on the circle. This is the given circle. Here x square plus y square equal 25. Center is origin, radius is 5. This is the radius. The required circles are, the locus circles are each radius 3, all are equal radius of 3. Centers lies on the circumference of the circle. Therefore, this is, suppose the point lies here, any possibility is there. This is the inner circle. Inner circle have the minimum distance of R modulus of R1 minus R2 equal to C1, C2. Therefore, we using this property, in this situation, the property is modulus of R1 minus R2 less than or equal to C1, C2 less than or equal to R1 plus R2. R1 plus R2 is the radius of the bigger circles. Therefore, modulus of 5 minus 3 less than or equal to root of distance between the two centers, root of x minus 0 whole square plus y minus 0 whole square less than or equal to modulus of 5 plus 3. Finally, the answer is 4 less than or equal to x square plus y square less than or equal to 64. This is the locus of the point in the set.